outside, x times -3 minus 3x. I is the inside, 3 times x. L is the, sorry, is the these two here, 3 times -3, which is -9. Is that clear?
Yeah.
You've seen that before, I hope, a couple times.
Yeah, but I saw it with the like for the outside, I saw it the inside to the outside.
So the order doesn't matter. Like as long as you get these 4 multiplications, x is multiplying x and -3. This 3 is multiplying x and -3. As long as you do all of them, that's okay. However you do, it's okay. Is that all right?
Yeah.
Okay. Now, what typically happens is the O and the I can be combined. Okay. -3x plus 3x, that can be combined there. What does that combine to?
Wait, what combines?
The -3x plus the 3x, those go together. They're considered like terms. Have you heard that before?
Yeah.
Okay. Like terms means that they can be combined, added or subtracted.
Oh, okay. So they would combine to be 0?
Yeah. So they go away. So what's left over is the x squared minus the 9.
Okay.
Okay. Now we're gonna answer this question here shortly about what a special product is, but let's do another example here. All right. Let me know if you need a moment to get this down. Like I said, I'll send you the notes here at the end as well if you don't have everything.
It would be.
Hi, Matthew. As Max is working on this, I just wanted to let you know I'm here now.
Okay, awesome. Yeah, we'll do some feedback at the end here, talk about some other stuff.
Okay.
Do you have any questions for me thus far?
No.
All right, Max, so let me know when we can move on to another example here. I'd like to give you one more to look at, think about.
Okay.
And
So is x squared minus 9 the special product?
it is, but I want to do one more example so that I can get you, in your own words, to answer this last part. But I think you need one more example to see the pattern here.
Okay.
Okay, so let's look at this one here. Let's go x minus 5 times x plus 5. Will you FOIL that for us, please?
Yeah. So I guess would be x minus 5 parentheses x plus 5 parentheses. You would put the
So you multiply the first, x times x. What does that become?
x squared.
Good. And then it's x times positive 5. What does that become?
X times 5x.
Plus 5x. Then the inner minus 5 times x.
Minus 5x.
And then the last minus 5 times minus 5. Sorry, minus 5 times positive 5.
Minus 25.
All right, good. So now again, you can combine the outer and the inner there, the O and the I. What do they combine to?
0.
0. So this becomes x squared minus 25.
Yeah.
Okay. So to summarize the two problems that we worked on, x plus 3, x minus 3 is x squared minus 9, x plus 5, x minus 5. Notice the order doesn't matter. Like if it was x minus 3, x plus 3, or x minus 5, x plus 5, the order doesn't matter here when you're multiplying. So these are what are called special products. What do you think? What do you see? Why are they special here?
Because you can just multiply the two x's together and the two numbers together, and
That's right. Exactly. And that's what your teacher is looking for when it says up here at the top here to use all language that is specific to this special case to describe the process and outcome of the multiplication. So
Mm.
exactly what you just said. The answer is always x times x, x squared, and then subtracting the number times the number, or which is the same number.
Okay.
So for example, like if I wanted you to do x plus 8 times x minus 8, the answer is x squared minus what number?
It would be x squared minus 64.
Yes, very good. All right, so take a moment to write that down if you need to. Otherwise, we'll move on to number 18.
I will write that. Um. Okay.
All right, so let's move on to number 18 here. I'm going to snip it into the screen and we'll take a look at it. So before we get to all the other words here, we're going to take a look at x plus 3 squared, which is this. It's x plus 3 times x plus 3. It's not the same as the last, and you have to write it out this way. You have to what's called expand it. Okay.
Okay.
You are going to FOIL again, like that's the same, no changes there. This time though, it's plus and plus, whereas in the previous problem, it was plus and minus.
Yeah.
Okay, so that's the key difference here. So we're going to do the FOIL. I'm going to have you help me out here with that. Can you go ahead and give me the first term here, x times x? What does that become?
X squared.
X squared, x times 3.
Plus 3x.
Okay, and then 3 times x,
Plus 3x.
and then 3 times 3.
9.
So what do you notice about these two terms in the middle here? What do you notice about them?
They're the same.
They're the same. That's important. So when you add them up, you get double what you started with. 3x plus 3x is 6x.
Oh yeah.
So go ahead and get that down. Like the last problem, we'll do a couple examples and see if you can come up with the pattern on your own.
And go. All right.
You got it?
Yep.
Okay. So let's look at x plus 5 squared, which is really x plus 5 times x plus 5. You want to expand. You always want to expand. Don't take any shortcuts. Okay. And then we are going to FOIL this. Use FOIL here.
Okay. So
So what does this become?
X squared.
Good.
Plus 5x.
Good. Keep going.
Then plus 5x.
Good.
Plus 25.
Yeah, and just like the last problem here, these are the same. And that's why this is a special product, is because it's always the same.
Yeah. Oh, because it's
Meaning that these always are the same. They always combine. You double them. to 25.
Okay, so they're special product because they're the same.
Well, they're special product because you can tell the answer without doing the work of FOIL. They have what's like a known pattern, basically.
Yeah,
Okay, so I've written the two problems here. So look at this 5, and how did it become 25? Well, you square it. Do you agree with that? 5 squared is 25. How do you
Yeah.
get the 10? The 10 is double the 5.
yeah,
So let's look at the one that you had for your problem here. 3 squared, is that 9?
yeah,
And then is double the 3 6?
yeah.
Okay, so here's one for you to try. And the idea here is you're not going to FOIL, you're going to use the patterns to write the answer.
Okay. So it would be x squared plus 16x plus 64.
Good. Let's have you try another one here.
X squared
Okay,
plus 2x plus 1.
good. Okay, so the good news here is you have this down, but we need to go back and we need to be able to answer this part, which is use all language that is specific to the special case to describe the process and outcome of the multiplication. Meaning you, Max, have to say what this pattern is. You have to describe how you go from the left to the right, like what ends up happening to do that. So can you tell me what you see, what the pattern is?
So you square both the number and the x, but then you kind of like double the number and add the x to the end.
Yes.
Okay.
So
So
let me know when you get that down. Take your time here. We've got plenty of time to do 19.
okay. Okay.
Got it?
Yeah.
All right, so we're going to move on to 19 here. 19 says, why is any base raised to the 0 power equal to 1? And they're giving an example. They're saying a, which is some number we don't know, to the power of 0 is 1, a not equal to 0. Use both numerical variables to present your argument. Okay. What do you think here? Do you have any idea how to start this, or what comes to mind when you work on something like this?
Well, I guess if a number is like done to the 0 power, it's not, I actually don't really know.
It's okay. I mean, I'm just asking. So I don't want to describe. I mean, this is like one of those things. Let's go back and talk about like what is 3 to the power of 5 mean? What does that mean to you?
You multiply 3 5 times.
3 times 3 times 3 times 3. Then I've got it there. Okay. And so if it's to the 0 power, how many 3s do you have?
None.
None. Okay, so you might wonder, well, why isn't it 0? Okay. And this is one of those things where it's like, well, it's the product of no numbers at all, is kind of the way of saying it.
Okay. So it's like, mm, mm. Okay.
There's perhaps a better answer of explaining this. Have you ever flipped a coin?
Yeah.
Okay. If you flip a coin, and we're going to do it twice here. You get heads, 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 tails, tails, heads, and tails, tails. Would you agree with that?
Yeah.
Now, this is a total of 4. And what is 2 to the power of 2, Max?
4.
4, right? 2 times 2, which is 4. So this 2 to the 2 is actually the total number of arrangements of these two outcomes, right?
Mhm.
But if you don't put anything on the table, like imagine 2 to the 0 means nothing is put on the table, there's no coin at all.
Mhm.
That's still considered an outcome because there's nothing that is there.
Yeah.
So the other way to do this problem, and I don't really know what your teacher wants here because this is a problem you'd see in a proofs class, but you probably saw this at some point. And this is maybe how you guys are supposed to do it. Let's say you wanted to find 2 to the power of 5, okay, which is 2 times 2 times 2 times 2 times 2. Okay, but we break up 2 to the power of 5 as 2 to the 0 plus 5, which is 2 to the 0 times 2 to the 5. I don't know if you've seen that before. Maybe. Well, just go with it for the moment here. So it's 2 to the 0 times 2 times 2 times 2 times 2 times 2. We know that 2 times 2 times 2 times 2 5 times is 32. So if this is 32, what must 2 to the 0 be to get you to 32? Meaning like we can't change this number. So
Yeah.
it must be
4.
1. 1 times 32 gets you back to 32. All right, let's just spend one more minute here. I don't know, do you need some time to get something down here for your answer?
Sure.
Okay.
Um, um, okay.
All right, so we're going to go ahead and stop the lesson here for today. If